Over the last few videos, we've introduced you to different types of table joins using the actor, and film tables. Now let's explore beyond those three tables, taking a look at the rest of the database and look at some new ways to illustrate the concepts that we've talked about. As we can see from our ERD and pgadmin, there are plenty of tables to analyze in the DVD rental database. There are 15 total, and some of them actually describe the customers and their rental habits at our business. So let's zoom in on that part of the diagram where we can see our customer table, which connects to our payment table and our rental table. The rental table then connects to an inventory table, which connects to our film table. So what are we seeing here? The film table is a list of all the films in our business's collection. The inventory table has a combination of film ID and store ID, so it is showing us which stores have which films in their inventories. Then, the rental table is showing us which customers came to these stores and rented these movies, including the date the customer rented the movie and the date the customer returned the movie. The customer table gives us information about the customer, including name and email, and the payment table tells us which rentals each customer has paid for. There are some other relationships as well, such as to the staff table, but we're going to ignore those for now and focus only on the tables I just mentioned. Now suppose that our goal is to see all of the rentals by a particular customer. We want to know what movies did he rent, on what dates did he rent the movies, on what dates did he return them, if he returned them, and how much did he pay for each rental, if he paid for them. Let's start from scratch with a brand new query and write it out. We're going to start with our customer table, then inner join to the rental table using the customer ID. We're using inner join because we only want to return records where this customer definitely made a rental. Next, we will inner join to the inventory table from the rental table using the inventory ID. We're using inner join here because we only want rentals that were in inventory. Then, we will inner join to the film table from the inventory table using the film ID. Next, add the following columns to your select clause: customer first name and last name, film title, and then the rental date and rental return date. Notice how I'm prefixing each of my columns here with the name of the table it comes from. This is known as qualifying. Qualifying your table names is a good habit to get into with SQL because in a database it is not uncommon for two tables to have a column with the exact same name. We have several examples right in front of us. Customer ID exists in both the rental and customer tables, while inventory ID exists in both the inventory and rental tables, and so forth. If we add inventory ID to our select clause without specifying which table it comes from, and then try to run the query, we'll get an error saying that column reference inventory ID is ambiguous. Postgres doesn't know whether we're telling it to pull the inventory ID from the inventory table or the rental table. This is one example of when we need to be more explicit when we're writing SQL, so it's a good idea to qualify your table names. Let's remove inventory ID from our query and keep going. Next, let's select a customer by adding a where clause, saying where customer.customerID equals 336. Then add order by rental date. Now, let's run the query. We should get 30 rows. We can see that our customer, whose name is Joshua, has rented 30 movies from our database, including our favorite comedy, Snowman Roller Coaster, and something called Mosquito Armageddon, which we can only imagine is another one of those low-budget, off-the-wall horror comedy movies like the entire Sharknado franchise. I actually wouldn't mind watching Mosquito Armageddon. That sounds pretty great. But what else do we see in our results? We see that Joshua rented the movie Juggler Hardly on Valentine's Day 2006, but he never returned it. Oh, Joshua, I'm disappointed in you. Now let's add another inner join to our query, and this time let's connect to the payment table using the rental ID connected to the rental table and the customer ID connected to the customer table. And let's run our query. We suddenly went from 30 rows down to 22 rows. What just happened? Let's add a couple of columns from our payment table to see if we can figure it out. We'll add payment amount and then payment date. To figure out why we suddenly lost 8 rows, let's change our inner join on the payment table to a left join and then run this query again. And we see that 8 of our rows don't have any payment information. So our boy Joshua here got 8 rentals that he never paid for. So now we're seeing a better example of the difference between a left join and an inner join. Apparently our friend Joshua rented a bunch of movies, but he didn't pay for some of them. And we can see this reflected in the fact that he does not have any corresponding payment records for 8 of these rental records. We've discovered Joshua's bad habit of renting movies and not paying for them. So let's see if we can find any more customers who never paid for their rentals. First, let's remove the customer ID filter from our where clause, and let's replace it with a filter that says where payment.rentalID is null. Since we've removed the customer filter, what this query should do is return all customers and their rentals, correct? Except we've specified this filter condition in our where clause. What is this going to do exactly? This is known as an anti-join. The purpose of an anti-join in SQL is to locate records in one table that do not exist in another table. In other words, it is a perfect method to find rental records that have no corresponding payment records. It can give us exactly what we're looking for in our quest to find those customers who never paid for their rentals. By specifying a filter condition that the payment table's rental ID column should be null, we're filtering our result set down to only those records where a payment does not exist. And we run the query, and sure enough, we get 1,452 records in our result set, all of which display null in both the payment amount and payment date columns. We have successfully used an anti-join in SQL to find our customers and the rentals that they never paid for. Notice that anti-joins don't have their own syntax like other joins. I can't write out from table A, left anti-join table B, or right anti-join table B. The trick to anti-joins is writing that is null condition in the where clause, so you only return those records where the data does not exist.